All right, we're here at halftime with our star quarterback, Dalton. What's going on, Dalton? How do we feel about the game?
Coach, my wrist is broken. We've run this play 20 times and it's not working.
Oh well, still gotta play.
Coach, what are you thinking?
All right, here, bring it in. We've been running this play all first half. It's not really working. We're using PCC. We tried Jones reagent. It's too toxic. We got to move to something a little bit greener. So in household bleach, we've got sodium hypochlorite. When that interacts with acetic acid, the hypochlorite anion is going to act as a nucleophile and attack this hydrogen on the acetic acid and essentially deprotonate. Now, what's going to happen when that occurs is this acetic acid is going to turn into a conjugate anion, and it's going to be attracted to the sodium cation. And what we're going to be left with is this hypochloric acid, and that's going to act as our oxidizing agent for isoborneol. All right, if defense does what they're capable of and we get this hypochloric acid, that's going to be our oxidizing agent for isoborneol. Now, this is really important to pay attention to. Isoborneol is a secondary alcohol. That means that when it reacts with an oxidizing agent, that it's going to be converted into a ketone, which is going to turn out to be camphor. But the mechanism is super important, so I need all y'all to pay attention. All right, we've got our hypochloric acid right here. This alcohol is going to act as a nucleophile and attack this chlorine, and the electrons are going to transfer back to oxygen because oxygen is more electronegative than chlorine. Oxygen has an electronegativity rating of 3.5. Chlorine is just 3. So it's going to attack this chlorine, and this is going to be converted into water. Now, that water is going to turn around and again act as a nucleophile and basically deprotonate this oxygen. And what's going to happen is it's going to attack, these electrons are going to attack this hydrogen, then these electrons are going to transfer to the oxygen again because oxygen has a 3.5 electronegative rating. Hydrogen is only 2.1. So huge disparity. We're going to come out on the winning end right there. Now, again, this water is going to come back through and deprotonate this second hydrogen. And this is a hydrogen that's actually on our alpha carbon. Now, when that happens, we've got a 3-step concerted mechanism that everybody needs to pay attention to. Water is going to act as a nucleophile to deprotonate this hydrogen. The electrons right here are going to transfer not to the oxygen, but to the pi bond right here and create a double bond. As that happens, the third step is this chlorine is going to act as a leaving group. And so you've got a 3-step concerted mechanism that results in the production of camphor right here. See, we've got a secondary alcohol converted into a ketone right here. This is actually camphor, and the byproducts are H3O plus and Cl minus. So if everybody does what they're supposed to do, then we'll come out on the winning side and produce camphor.